All right, so we've done a lot of work with ionic substances, understanding how to write their formulas and write their names. And really, it's all about dealing with those charges. Because you know the charges, you can determine the formulas, or from the formula, you can determine the name. But here we're going to learn about covalent compounds. And remember, a covalent compound is the sharing of electrons. So you have two or more nonmetals that share their valence electrons with each other. And that sharing can happen in a lot of different ways, which means we have a different set of rules for covalent compounds. Luckily, I actually think they're a little bit easier than working with ionic compounds because we actually don't have a way to know exactly how many of each element should be in that compound unless somebody were to tell you. And luckily, that's how we name them. The way that we name a covalent compound is using a prefix. That prefix tells us how many atoms are in that substance. So I want to give you an example. This would be the name of a covalent compound, dinitrogen tetraoxide. It's made of nitrogen and oxygen. And so we actually know right away that this has to be covalent because nonmetal, nonmetal. So the way that we work with these is we just take the substance, so nitrogen. We take the prefix 2, that's how many nitrogens there are. We take the substance, oxygen. We take the prefix, tetra, that's 4 oxygens. So dinitrogen tetroxide is N2O4. Previously, if this were an ionic compound, we would have reduced it, and it would have become NO2. But do not ever reduce a covalent compound. Covalent compounds are very, very different. And so they just form a substance. Whereas remember that ionic substance formed a crystal lattice. And that crystal lattice is what made us actually reduce the number. Here, because we're dealing with a covalent compound and it's sharing those electrons, we do not reduce the formulas when we work with them. So I wanted to show you, there's really only a few other tricks here. Let's say I had something like CO2. Now, CO2, I know I'm dealing with carbon. And I'm dealing with oxygen. The way that we name these, I know I have 2 oxygens, so I'd write di-ox. And then we actually are going to change the ending of the name to IDE for all of these. There is never going to be a polyatomic ion because there's never going to be an ion. So CO2 becomes carbon dioxide. You may be wondering, why didn't I write monocarbon dioxide? Well, when we have just one of the very first element, we don't write the prefix mono. So I don't have to say monocarbon dioxide. When I write carbon dioxide, it's just assumed that I meant only one. If there's any more than one, I would have written a prefix. But what if I had something like CO? Well, there's only one carbon, so I would just write carbon. But because this is the second element, oxygen, I need to write a prefix for it. And since there's only one, I would write monoxide. Remember, changing the ending in the name to IDE. So this is how we work with covalent compounds. It's just about using prefixes and changing those into formulas or changing those formulas into names. Really, the only trick here is don't write mono if it's the first substance and there's only one. Do write mono if it's the second substance and there's only one. But the biggest thing that you can do right now is go practice. Make sure you try this out, and you should make sure you can try figuring out if something is ionic or if it's covalent. And remember, we do that by looking at, does it have a metal and non-metal, or is it 2 non-metals? But make sure you go practice. Good luck with this. If you have any questions, make sure you ask, and thanks for watching. I'll see you next time.